Hi, so in this video we are going to talk about state design pattern. Now before getting into what is a design pattern and how do I implement this, let's first try to understand what this state design pattern tries to solve, right? And how it is being used in modern software development, right? Now, before understanding or before getting into the details of state design pattern, first we have to have a brief understanding about what a state machine is, right? Because this entire design pattern is based on a state machine, right? So what is a state machine? Essentially, it's just a mathematical model, or you can think of it as a theoretical machine where there are a bunch of states and you hop around the states based on certain conditions. Okay, and typically we draw these states using round circles, right? So you can have a bunch of circles here, right? And then based on certain criteria I can jump from one state to another state. So for example, I make use of, just take the free flow pen, and let's say this is my state A, this is my state B, right? Now let's say I'm standing on state A right now and certain conditions happens to be true, so I make a jump on state B, right? Now it might happen that there is some condition that again triggers a jump from state B to state A, right? So if you look at this way, I am able to jump from state A to state B, and this is what a state machine is, right? This is called as the state machine. So let me just quickly write it here. This is the state machine, right? And basically, so this state machine is essentially used, or it's a mathematical way of representing your complex systems, right, on a sheet of paper, right? This overly simplifies the implementation details of how a machine is going to work under the hood, but what it rather focuses on is how a state will change, or how a machine would change its state when certain conditions are met, right? Let me take a concrete example just to make you understand this better. So instead of taking A and B as a state, I have two states for now again. So I'll be taking a video player example and we'll try to see how we can model such a complex system using a state machine, and then we'll try to replicate in the code itself, right? So we'll try to have our own simplified video player, right, which will have some sort of basic functionalities, and we'll see how a state machine mimics this video player, right? Okay, so I'm trying to draw a state machine for a video player. So let me just give a heading here quickly. Let's start with designing the state machine, right? Now, as I said, a state machine is just nothing but a bunch of states, and then there are some transitions happening based on certain conditions, right? Now, what all states are possible? Let's say, let me just have a play state, right? And I can also have a pause state. So every video player has a play and pause button, isn't it? Now, apart from this, can I have more states? Definitely. So let's just copy the circle, and let's say I have another state called as a lock state, right? Now, what is a lock state? So every video player has got a lock button. Basically, by clicking on it, you basically freeze the entire screen, right? So all the other buttons gets disabled when the screen is locked, right? So there could be a lock state, right? We can say that the video player is in a lock state, isn't it? Now, what else? We can also have something called as forward and backward, right? That could be one functionality, I would say. But is it a state? No, it's not a state, right? So what else can be called as a state? So play, pause, stop. So stop and pause are going to be the same thing. Lock is going to be a state. Lock and unlock would be, you can consider them as two separate states, or you can also make them as a single state. That depends on the complexity or the granularity you want to design your machine with, right? Just for the sake of example, we'll keep it simple. We'll not have much states, but the idea is that you can basically decompose any complex system into multiple states, right? So for example, a video player can have play, pause, and lock as three states for now, right? Okay. Now, how do I make transitions? Now let's see that also. So let's say I take the free floating pen now, and all right. So now, if I'm in the playing state, let's say my video is playing right now. So if I click on the pause button, what will happen? To which state will it transition, or to which state it will move? It will definitely move to the pause state, right? So I can clearly draw a pause state. So if I click on the pause button, I'll simply move to the pause state, right? Now, if I'm in the pause state, what will happen if I click on again on the same button? What will happen is I'll simply move back to the play button, right? Or the play state. So if I click on the play button, I'll simply move to the play state, isn't it? Okay. Now let's say if I'm playing the video, right, and let's say if I click on the lock button, what will happen? I will move to the lock state, right? So I have locked the screen. Now once I'm in the lock screen, can I play the button? So can I do play or pause? No, that's not possible, right? So lock screen will keep the video player in a state where it is, so basically the lock screen would basically freeze all the buttons, right? So that's what will happen in a lock screen. Okay, what about if my video is paused? So if my video is paused, let's say in our video player we do not allow anything, any video which is in pause state to move from pause state to lock state, right? So whenever the video is paused, the lock screen is also disabled, right? So we do not have a transition here. Okay, it might not be true for a real world case scenario, but for our simplified video player, we'll keep this transition this way, right? So let me just repeat this again. If we are in the pause state, we will not allow our video player to go into a lock state. Only when we are playing the video, we can move to a lock state, right? So this is the basic understanding about our video player, right? And it's just not about the video player, right? If you talk about any system, there are a bunch of systems which you can think of which require such state machine under the hood, right, to operate properly. For example, let's say I talk about the authentication system, right? Let's say you use any account. Let's say, for example, you log in into your Gmail, and until unless you log in, you do not have the option to log out, nor you have an option to change the password. So only after you authenticate yourself properly, right, you have these options enabled for you, right? So if you can think of this authentication system, this can also be broken down into a state machine where you have a bunch of states. For example, one is login state, one is logout state, and once you log in into a system, then you have other options available to you. For example, you have the option to change the password, you have the options to log out, you have to change, you also have the options to change basic info, right? All these things are not possible if you are in the logout state, right? Or let's say if you try to log in into a system and you get into, you enter multiple times wrong password and your account gets locked. So then you move to another state called as lock state, right? And for that, now you need to verify using OTP or an email ID, something like that, just to unlock yourself, right? So again, if you see here, the authentication system also implements a kind of state machine under the hood, right? Now another example could be your vending machine or ATM kiosk, right? So where you withdraw cash. Now again, it can again be broken down into a state machine, right? Wherein the first step is always to insert the card and the PIN number. Now until unless you enter the correct PIN number, you don't see the options of withdrawing the cash, checking your balance, changing basic info again, right? All these things are not possible if you do not enter the correct PIN, right? And so again, if you see, the machine also moves from one state to another. So initially it is in the accepting state where it is expecting for you to enter a card and the the PIN, and once you enter it properly, you move to another state called as the authenticated state, and in that state you have a bunch of options to play around with, and depending again what action you choose, you move to some other state, right? So this is how any complex system can be broken down into multiple states, and their relationship can be established using these transition diagrams, right? This state machine is also called as a transition diagram, okay? And also, just to tell you, every state machine has a starting state and has an ending state. So this is very important to know that every state has a starting state and an ending state. So for example, let's say in my video player, right, I'll mark this as my starting state, okay? So currently in my state transition diagram, lock seems to be as a ending state, because if you see, there is no outgoing or outward arrow from this lock state, right? So once I move into a lock state, the only way to come out of this lock state is to basically do myself as an unlock, right? So I think I should also draw a state transition here, right? Because then I'll be locked forever in this lock state, right? So let's say if I'm in the lock state, I have an option to unlock myself, and if I unlock myself, I'll again go back to the play state, right? So let me just quickly draw this way, and then if I do this way, I can just go back to my play state, right? Now in this state transition diagram, play acts as the starting state. So why is this starting state important? Because it's very important, because So whenever your system starts, it has to start in one or the other state, right? It need not be the states which you have mentioned. So in many systems, we have a dedicated start state, right, which initiates the entire state machine. And then from there, we move to different desired states. Now, having said all this, now, how do I put this state machine into code, right? Now, that's the next big question, right? Okay. Now, before getting into that, let's also try to understand the functionalities which each of these states offer, right? That's also very important to lay down first, right? So, okay, let's first list down all these possible functionalities a video player can have, right? And then we'll bunch them together into different states, right? So my video player can do a play, it can do a pause, it can do a lock screen, right? So I can basically lock my screen. Then I can also do an unlock screen. Okay. Okay, what else I can do? I can also do a rewind, right? So I can rewind my video. Okay. And what else? I can rewind. So rewind, then there could be also forward, backward, then you can also zoom in, right? Then you can do full screen. All those things are there. So there can be n number of options or functionalities which a video player will have, right? But let's again stick around with this bunch of functions so that it's easier for me to code and show you how a state machine can be translated into a code, right? Okay, so we'll just play around with these 5 options, right, or 5 functionalities, and we'll try to mimic this video player, right? Okay, now what I want here is that I want all my states to implement all these functionalities. So looking at these functionalities, now what we'll do is we'll make sure that these functionalities are implemented in all these states. Okay, now you might argue that okay, options like rewind, unlock screen, or let's say pause and play are makes no sense in the lock state, right? Because once you lock the screen, rewind, play and pause all get disabled, right? And that's very obvious, and that's arguably correct, right? But still, we want all these functionalities to be implemented in all of these states, and we'll try to optimize this later on, right? We'll try to see how we can remove this redundancy of code. But for now, just to start simple, we'll make sure that all these functionalities are implemented in all these different states. Obviously, the implementation for these functionalities will differ from state to state basis, right? For example, in the lock state, rewind option function would be there, but it would return a error or a message on the screen that you are in the lock screen mode and therefore you cannot rewind your video, something like that. But let's say if you're in the play state, the rewind functionality will rewind your video by some seconds, right? Okay. Now, having said this, why are we trying to model a machine or a complex system in using a state machine? Now, there is a very good reason for this, right? A state machine essentially abstracts out all the functionalities, right, and manages the transition between the states, right? Therefore, the object or the instance variable need not be worrying about how these transitions are happening. What I mean by this is, let me explain with an example. Let's say I have a instance of a video player, right? And let me call it as a YouTube player, right? It's an instance of a video player right now. Now, the transitions of this video player are independent of another instance, right? Now, every object will have its own state machine running internally where the video player would be getting transferred or would be oscillating between these states, right, independently of another video player instance. That's the first point I want to make here, right? So every object will have its own state machine copy. That's something to be understood, right? It's not that the state machine is a common machine which will take care of the life cycle of all the objects, but rather every object will have its own state machine. Okay, now having the state machine, right, what it does is it basically abstracts out the logic for all these functionalities from the object, from the video player object, right? So the video player object need not worry about how the play, pause, lock screen, unlock screen, and rewind functionalities are implemented, right? Because now all these implementations have become state specific, and the states will take care of that, right? Therefore, we are basically loosely coupling the video player object and the state machine, right? Now let's see by drawing a object for a video player. So let's say this is my video player. So I call this as a VP, which is my video player instance, right? Now every video player, this is going to be an object for a video player, right? Now this in the world of design patterns we also call as the context. So if you have read design patterns or state design pattern anywhere else, or if you read it on the internet, you'll find that people tend to call this object as the context, right? Now, this context is basically, so we are basically removing the logic, implementation logic from the context and putting them in the state design pattern, right? So the states basically hold the logic of implementation, right? And how does this context know to which state it belongs to? So basically for this, what happens is, within this context or within this video player object, we maintain a current state, call this as current state. So this current state is a reference variable which basically points to whichever state it is in currently, right? So if the current state points to pause state, that means the entire context is currently in the pause state, right? So just to visualize, right, what you can do is you can always think about something like this, that there is something like this which is pointing to this pause state, right? So if my current state value changes to, let's say, log state, so this arrow basically now points to this log state, right? So so now it means that the context object is in the pause log state. Similarly for play state, right? And whichever state it belongs to, depending on that, these functionality implementations or these implementations will change, right? This is the whole idea here, right? So when we create a context, we'll always have a current state, and this current state will always point to one of these states, right? Now here comes very important understanding about interfaces, that in order to achieve this sort of representation in programming, we need to make use of interface. Why? Because if you see, these states are all different, but they all implement the common functionalities, right? So basically what I can do here is I can abstract out all these functionalities into an interface, right? And I'll make sure that this current state is of interface type. Okay, this way my current state reference variable can point to any of these states, because these states are going to implement that interface, right? So just for the sake of clarity, let me just write something called as the state functionality. I'll call as state functionality, and this is going to be an interface, right? So okay, so within the state functionality, all these functions are going to be there, and all these states are going to be basically implementing the state func interface. Similarly, this current state will also be of type state func, right? This way I can allow the current state to basically point to any of these states, right? So now let's go to the code editor and try to implement this interface, right? Okay, so first let's start with the implementation of the interface, right? Now what I want is I want to create different states. So as you can see in the diagram here, we have around 3 states. So I'll try to create 3 different structs in Golang, and which will all implement this interface, right? All right. So I have these 3 states available to me now. What else? Now these states need to implement this interface. So in Go, right, we don't have an explicit implementation. Just like Java, we use the implements keyword. Go has something called as implicit implementation. So once this struct implements all the functionalities of this interface, we say that the given struct implements the interface, right? So let's do that now quickly. Okay, so we have implemented these functions, right? Now since this play state is implementing this, I can say that play state implements state func, or the state functionality interface, right? Okay. Now similar thing has to be done for all the other 2 states also. So let's quickly copy everything. All right, so now I can say that all these 2 other states also implement the interface. So now before getting here, what we can do here is, so we have to specify the specific implementation for all these functions based on the states in which they are, right? Now for example, if I'm in a play state, what I can do here is I can simply print out. So if I'm in play state, can I play the video? Yes. So I can say that, so I say that my video has started to play. Does it require any transition? Now think about this. Let's say you are in the play state, Okay, let's say you're in the play state and now you're clicking on the play button. So will this make any transition to any other state? No, can very well stay in the same state, right? So we are not going to make any transition over here and we will continue to stay in the same state, right? What about pause? Let's think about this. So if I'm in the play state and let's say if I click on the pause button, that means I have to make a transition to the pause state now, right? Because once I move to a pause state, the scenarios or the implementation changes because now the video has been in a pause state. So I can simply say here println and then I have to make a transition. So I'll make a transition here, transition to pause state. For now, I'm just keeping it as a marker. We'll come back later and we'll update this, right? Similarly, what about rewind? Now imagine that you're standing on the or you're in the play state. Now can I do a rewind? Definitely. So I can simply take a rewind option here and let's say video rewinded by 5 seconds, right? And if you want to add a logo here, you can simply put a rewind logo, right? Okay, now if you are in the play state and if I click on the lock button, what will happen? So I can simply say lock the screen, right? So lock screen, that's it, right? Let's say for again for the sake of thing, let me just take up a lock. So I've locked the screen here, right? So and once you lock the screen, what will happen? You have to move to a lock state, right? So again you have to make a transition here, transition to a lock state, right? To do this, what about unlock? So if I am on the play state, can I unlock myself? Not really, right? Because you can only unlock yourself when you have actually locked the screen. So this function has actually no meaning when when you are in the lock or when you're in the play state, right? So this is useless, I would say, a useless function. So I can simply throw an error, something like this. But right now I'll not throw an error, just to keep things simple. What I'll do is I'll just print on the screen, unlock not allowed. And do I need to make any sort of transition from this play state? No, right? So basically this function, so here I'm just printing on the screen, but in reality, right, this option would be disabled because this function has no impact when you are in the play state. So in reality what happens is this option is always disabled, right? So I'll say this option is kind of disabled if you are thinking in terms of a GUI perspective, right? So this option won't show up when you're in a playing state. This will only come up when you're in the lock state, right? Okay. Now, similar thing can also be done for the other two states, right? Okay. So just to walk through all this again, let me just again do this quick exercise. Imagine now, see, now I'm in the pause state, right? Because now I'm trying to implement the functionalities for the pause state. So now when I'm in the pause state and if I click on the play button, what should happen? So if you're paused and you click on the play button, so your video should start playing, right? So I would say that video started playing again, started. And now I think you would have guessed by now that now we have to make a transition back to the play state. If I go back to the diagram again, so if I'm in the pause state and let's say if I click on the play button, so what happens is I again move back to the play state, right? This is what I'm doing. So same thing I can implement in the code also. So what I do is I'll simply do a transition to a play state. I don't know why I'm doing so many of typos. Transition to play state, right? All right. What about you're in the pause state and you click on pause again? Basically, this option shouldn't be available. So this must be disabled in pause state, right? Because it makes no sense to double pause the video, right? So I can say that simply println. Again, I can say similar thing, right? Let me just take a just copy paste here, and I can say that pause not allowed, right? And I can give a warning signal here, right? What about rewind? Is rewind allowed in a pause? Maybe, maybe not, depending on the video player you are implementing. But let's say my video doesn't allow a rewind option again when you're in the pause state. So again, I can put this as also as a warning sign, so that rewind is also not allowed, right? Okay. What about lock? So if I'm pause, can I lock my screen? So in our initial machine diagram or machine state machine, we did not have a transition diagram or transition arrow from pause to lock state. So let's stick to this diagram only. So lock not allowed, right? What about unlocking? Again, same thing applicable here also, that you cannot unlock because you cannot unlock itself, so you cannot unlock also. So if you see here in this pause state, all the functionalities are disabled until and only the play option is available, right? So you can only play in a pause state, but you cannot do anything else, right? All right. Now coming to the lock state. By now I think you can guess what I'm going to type here. So if I talk about the place, so when I'm locked, I am not allowed to do anything apart from unlocking myself in this state, right? All right. So in unlock state, right, what I can do here is I can unlock myself. So I can say unlocking the screen, right? So I've unlocked myself. Let's see if we have any diagram for unlocking. Yes, so we have a padlock here. And once I unlock, I can also do a transition to play state, right? So if you look at this, this is the implementation for these states, right? So we have implemented all the functionalities which are there, which we have mentioned here in the interface. Now what's next? Now once you do this, right, now what we have to think about is we have to think about the context or the main object which is going to use this state transition diagram, right? So let's go and create our video player, right? So now what all I want in this my video player? First of all, I would want to have a name here, right? I want to give a name to my video player, right? So that I can distinguish between different instances of the video player. Second thing I want here is that my video player should have a current state reference variable. So if I come back here again, so if you see here, there is a current state reference variable of interface type, right? So that using this variable, I know in which state my current context lies. So for this, I'll say current state, and this will be of type this interface. So take the state interface. Okay, fine. Now what else I want to have here? Now the next thing I want here is I want to have a reference variables to all of these states, right? So here in total I have 3 states, so I have 3 reference variables. I'll tell you the reason why I'm having these reference variables apart from this current state, right? So I'll have a play state, so I'll have a play state func interface. Then I have also a pause state. So I have these 3 reference variables apart from my current state. Okay, now what else? Do I need anything else? For now I don't see anything, so let's proceed with creating a constructor for this thing. Now unlike any other programming languages like Java, C++ and all, we don't have a constructor kind of syntax in Golang. What we have is a factory method. So we can say that a new video player, right, and this function essentially returns me a instance to the video player. All right, and this constructor, or I shouldn't call this as a constructor, I should call this as a factory method, but so this will take a parameter for the name, right? And what it will do is it will create an instance variable. So the name will be initialized as it is, coming as a user input. So I will initialize the name for my video player. Now talking about these things, right? Now what I also want here is that this state machine, right? Let's get back to this diagram here. Now this state machine so far are not capable of making a transition. So if you look at the code also, I have just written a comment that a transition should happen when a pause button is pressed in a play state, right? So this transition would happen, but for this transition to happen, right, these states should know about each other, isn't it? There should be some way that the state play should know about the state pause, and this pause should know about lock. So essentially this is one of the key differences between a state machine or a state design pattern or a strategy design pattern. But the state design pattern is essentially different from the strategy design pattern. That is, the states are aware of themselves, right? So in a state machine, the states are very well aware that how many other states are available and to which state one can move from a given state, right? So in order to bring this awareness, right? So for example, so in this diagram you can see that there is a transition happening, but in the code we haven't done anything so far which will help this state to know about the other states, right? So for this, what I can do here is I can bring in some reference variables, right? So what I'll do is, so instead of using, so what I've done here is, let's go back to the play state here, right? So in this play state here, let me just add the context variable. Now I'll explain you why I'm using this approach. Okay, so I'm basically adding this video player here, right? And just to keep things simple, let me say video player. So essentially this state play has a reference to this context. Okay, so the video player here is the context here for us. A similar thing can also be done for all the other remaining two states. So where is the pause state? So here is the pause state, and where is the next state, which is the log state? So here is the log state here. Okay, now why am I doing this? Now there is a very important thing to understand here, the reasoning behind this, right? Okay, so let me just try to draw this again. Let me use some other color this time. Let me use a green color, and let me call this as this way, and let me just reduce opacity here. Okay, okay, now this play state, okay, let's take this pause state for now. Okay, now this pause state has a reference variable to this context, right? Now what does that mean? That means what I'm doing here is, why am I introducing this context reference variable in each of these states? The reason is, basically I'm trying to have a transitive relationship. Okay, what do I mean by this? See, in a given scenario, what would have happened is, let's say there are 25 states in my state machine. So does that mean I need to give 24 different reference variables in each of these states? Because if there are 25 states and excluding the current state, there are going to be 24 reference variables, so that this state knows about this state knows about this state, and let's say if I have multiple modes, so I will be referencing to all those different states, right? So this is not a good design approach, right? Because I shouldn't have so many reference variables pointing to each and every distinctive states in a state machine, right? Here the number of states are very less, so you can directly have all those 3 different state reference variables, but I will not do this given that it's going to be a production code, right? So what's an alternative to this? So a good alternative could be, so instead of having this direct relationship of all the states and the states bothering about how to contact each other, oops, what I can do here is, rather I can basically make a pointer. So let's say, so what I can do here is, I can reference to this context, right? Let's say the pause has a reference to this context variable or the video player thing. We can also call this as a VP, right? So we are referring to this VP object. Now this VP object has all the entries for all the references to all the states, right? And now I think you will be able to understand why in the video player, right, I created all these different states or reference variables for all these different states, right? Now what I've done here is, so essentially from the states I can directly go to the context object, and depending on where I want to move, I can take that particular object, and then I can make a final transitional call to this play state, right? So in this theoretical state machine, I drew a direct transition from pause to play, but in reality the transition would happen that from pause, first I will move to the context. From the context, I'll grab the object for this play state, and then I'll make a second jump. So essentially this is going to be this way, right? This is how we are going to implement in the code, right? So this is called as the transitive relationship, right? So instead of directly going from play to pause to play, I'm taking this route to reach play. And this is what is going to be used for all the other transitions also. So this is what is going to be the approach which we are going to employ, right? So now why is this better? Because this makes your states independent of the count of other states in the state transition diagram. See, this is where the strength lies for this state design pattern. The state design patterns gives us this flexibility that in future, if you want to add more number of states into this state machine, you do not have to touch all the states, right? The only place you have to make changes is in the context object, right? So all the changes confined to a single place, and by just making a single changes in the single place confinement, you can basically make sure that your states are having minimal changes so that you can still run this state machine, right? So this is where the flexibility of state machine lies in, right? Okay, so now since I've added the reference variables in the states, now basically these state machines or the states can now refer to this video player context. Okay, now while I'm initializing this context object, I also need to initialize the references to all these objects, right? So what all references I have? So one reference is regarding the play state, right? So I have this play state, v dot play state is going to be equal to, this is going to be equal to the play state. Now what I'm doing is I'm basically creating a play state here, right? So I'm creating a new instance of this play state here. Therefore, this is bringing the object into the memory. And now when I'm initializing the play state, what I'll do is I'll also pass the reference over here. So what I'll do is, since it has a video player thing, so it has a video player reference. So here I'll pass my v, right? So here I'm creating the reference variable to the play state, and I'm passing the video player, which I've already created above. So I'm passing this reference to this video player, and then whatever play state object gets instantiated, that I'm basically assigning in the play state field. Okay. Similarly, pause state will be equal to like this. So this is also here, and same code will go here again, right? Similarly, there is something called as the log state, right? So we'll also have a log state, which is going to be nothing but a log state here. So again, I'll have a video player here, and which will again have a v reference. Okay, fine. Just to reiterate, what I'm doing here is, let me just open it up, and all right. Now let's see what I'm doing here is. So let's try to understand this piece of code. So when I'm creating a play state object, what I'm doing is essentially I'm creating an object of the play state or the play, right? So I've created a play state object here, and I'm passing the reference to a video. So this v essentially points to a video player context. So I've already created a context, right? And I'm calling this as vp, which is done here, right? And now what I'm doing is, now this reference variable essentially points to this. This is what I've done here. Same thing I've done for pause state. So when I created a pause state here, I assign this v and I make this v to point to this. Similarly for the log state. So for log state also, the v is now essentially pointing to this. So this is the scenario which I've done here. So this is what I've done here in the code. Now let's see. Now the next and the final thing that we have to do is we have to assign the starting state to the current state. So this variable which we created, right, this will hold the reference. So my current state, or I should say v dot, because this is going to be a current state is equal to what? It is going to be one of the states, right? So let's say I said that I'll start with my play state, right? So I say v dot play state, right? So I have assigned my play state here as my starting state, right? Now, so this is the complete construction of your factory method, which will basically instantiate your context object, as well as it will create the state transition diagram, right? As I said in the beginning, that every context object will have its own internal state transition diagram or the state machine, which it will use for its operations, right? So if you see here, whenever I'm creating a new context object, I'm also creating these states, and I'm also linking them together in such a way that every context object will have its own copy of state machine, right? So I think this should be clear for now, right? Okay. Now, given that I've done all this referencing and linking of all the states, now I can go back and I can write this transition logic, right? Let's go back to the play state again, and yeah, so here it is like, right? So I have to make a transition to the pause state. So how will I do this? Now if you look at this ps dot, now this has this video player object embedded now, right? So we have embedded the video player object, right? So now we have this ps dot video player dot. If you look at this, we also have a current state. Okay, now one thing I have to make sure that it's a good design practice that you always make these transitions through a function rather doing directly assignment, right? So let me also quickly create a video player function, right? Just put it over here. So it's going to be a function which will say vp star this, and this will say transition to. Okay, this function will take a state, so it will take a state, and this will be of state func type. So basically this is going to be of interface type, so that I can pass in any of the functions or any of the states, right? Okay, and what this function would do is vp dot current state. So this will assign vp dot current state equal to state, right? So this handles. So now video player dot, now I can call this transition function here. So transition to what? So I want to make a transition to pause state, right? So how will I make a transition now? ps dot, now again I'll take the video player into account and I'll say move to pause state, right? Now if you see here, this is the transitive relationship I was talking about, right? So when I wanted to make a transition from the play state, right, to a pause state, what I'm doing is I'm first grabbing the video player object. That is, if you come back here, from the from the play state, I'm first grabbing the object of the video player, and then within that video player object I have a reference to this pause state, right? So I'm first moving to this context, and then from there I'm getting the link for the pause state. So this is what I'm doing here also. So I'm grabbing the object and then I'm getting to the pause state, right? A similar transition can be done in other places also. For example, here I want to move to a lock screen state, right? So I'll say ps dot video player dot transition to. So I'll call the function here, and now I have to pass the state where I want to make a jump. So I'll say again ps dot video player dot. So okay, so video player dot lock state. So I've done a transition here also. Okay, where else? Okay, here also I have to make a transition. So how do I do this? I'll say ps dot again. Now I think you got the drill. Dot transition to, and I can say ps dot video player dot. So this is the pause state. So where I have to go? I have to go to the play state, right? So I have to go to the play state here. So this is the lock state. So I have to ls. So now I have also drawn the transitions, right? Now I think this is, we have done the transition also. Now what else we can do here? Now is it complete? The state machine is complete. Okay, so if you look at this state transition diagram, you can find that at a high level there are three components to it: the states, the transition among the states, and this context object, right, which holds a bunch of all the references to all the states, isn't it? And now basically, and if in the code also you can see that we have done all the three. So a state machine is complete. Now I need some client APIs, right, or functionalities which the client code would use such a way that they can do this state transitions, right? Because remember, these state functionalities are hidden from an end consumer perspective, right? So they are not exposed, they are all hidden, they are all internal to an object, the context object. So I'll implement certain client APIs. So for example, let's say for the video player itself, I'll have vp star, let's say I'll say a play. So just to distinguish, now I'll call this as a play button, right? If you can think of this play button is going to be the backend code for your play GUI. So that button, right, whenever the user clicks on this button, this play button gets triggered, and this will call the underlying functionalities. So what I'll do is I'll say vp dot. So if you look at this current state dot play, that's it, right? Let's try to understand this. So what I'm saying is, whichever current state the current context is, just run that play button or the play functionality of that current state. This is what I'm asking it, right? So if the context is on pause state, the pause state play button would, or play functionality would execute, If it is on the play state, the play functionality of the play state would execute. If the context is on the lock state, the play functionality of the lock state would execute, right? Now you can see the beauty, right? Now the context or the video player object need not worry about the underlying state. It is automatically governed and taken care by the state machine itself, right? Similarly, let me also have few more functionalities. We have a play button, we have a pause button, we also have something called as the lock button, right? So when I'm here, I'll call this pause, right? So this is causing the pause functionality, and this is calling the lock functionality. So I'm calling the lock screen, right? Okay, and let's also call the unlock screen, right? So unlock button, and call this the unlock screen. Okay, so now these are the 4 APIs which the end consumer can consume or can make use of. So let's say I create a instance variable call as the new video player, and let's say I call this my video player. This is the name I'm giving here. A vp dot, let's say I call this as a play, so I call the play button. I will also again call the play button again. Let's see what happens if I call the play button again, right? And then I call the pause button, right? So let's see with these 3 buttons called in one by one. So let's see after calling these 3 buttons in succession, what is the output here, right? So if you see here, my video started to play, and since it's playing, calling the function again will not make any difference, right? Because since it's playing, calling the play function again or clicking on the play button again will not pause the video, right? So same thing was also there in the transition diagram. So calling the functionality again and again would not impact a transition, right? I should have drawn this diagram before itself, but I made a mistake, or I just forgot to add this. But this will essentially have a self-referencing arrow like this. Okay, so let me just make it consistent again. So I'll take this free marker. Okay, so this play has a self-referencing. So if I click again on play, standing in the play state itself, I will be again in the play state itself. So this will not create any transition to any other state, right? And this is what can also be seen in the output. But now when I'm basically clicking on the pause, I go to the pause state, right? Okay, now let's try something else. So instead of after pausing, let's say, can I call the lock state or the lock button? Can I make a call to the lock button, right? And let's see the output. Okay, now if you see here, video going to get paused, so therefore we are in the pause state, and now lock is not allowed, right? So when you pause, you are not allowed to lock the screen, right? And the same thing was seen here also. When you're in the pause state, you're not allowed to do anything with respect to locking of the screen, right? Okay, so I've locked the screen. Okay, let's say if I say play again, let me call this play button again. Can I see anything else now happening? Okay, so video has started to play again. Now why has the video started playing again? Because it was already in the pause state, right? Now can I do a rewind here? So let's say, okay, I think we did not give an option to rewind. Okay, so there's no rewind button here, so we have to implement that rewind button also. Quickly, let's do that also. So after locking the screen and unlocking, I'll also have a rewind button here. So rewind, and this should basically call the rewind screen, right? Or the rewind functionality. So if you see here, we have rewinded the video 5 seconds. Now just to see that whether we are doing it correctly or not, let's just write 2 bunch. Let's say I call the pause button itself. So I'll call the pause button, and then let's say I try to rewind the again, right? So if I try to do a rewind button again, and let me just comment these things out. Now let's see whether the code works or not. Ideally it should not work, because once you get into the pause state, you cannot do a rewind option. That's how we have written our video player, right? See, video going to get paused, so basically it has got into a pause state, and now rewind is not allowed in the pause state, right? So I hope that what a state machine is and how we write a state transition design pattern or a state design pattern is understood to you. This is a very crude way of implementing the state design pattern. Why? Because there are a bunch of things that can be optimized here in this piece of code, right? So one place where we can find a room for optimization is that there are many of these functionalities were disabled in most of the states, right? So we don't want to implement some dummy things for these functions, right? Because this leads to code duplication. So if you see here, this unlock not allowed and such warning messages are very common for most of the functionalities in pause and lock state, right? So is there any better way we can do this? Do we need to implement this again and again, right? So one better approach to deal with such repetition is to create a default implementation, right? It is one of the very easy ways to mitigate this problem, right? So let me just quickly take another copy for this. So we are going to take the same running example. This is going to help us in mitigating all these duplicate codes, right? So what I can do here is I can have a default implementation for this interface for all these functionalities, right? And then what I can do is I can use that structure to embed into the states, right? This way, if I'm not providing any of the functionalities explicitly, the default implementation would be used, right? This is how you can do this in Golang. Similar approach can also be done in any other language, right? The idea here is to have a default implementation, right? So let's quickly have a default implementation for all these things. So I will just copy paste most of the things. So let me just take it from here. So let's say I have I'm taking this as the message. You can have your own implementation, right? This default state will not do any sort of transition also. This basically ensures that if your state doesn't has any particular implementation, these implementations will be used by default. Okay. So this is play, this is ds. So all right. So we have this default implementation or the default state. And now what I'll do is I'll basically embed this structure in all of my states. So play state, pause state, and then I have a lock state, right? And now once I've done this, I can simply get rid of all of these implementations. So I don't even have to write this code, right? So the only functionality valid in the pause state is the play option. So this is, I've given my own implementation here. In the lock state, again, all these implementations are disabled. So I can simply pause, I can simply comment them out. And what else? Okay, only unlock screen is important. So this is there. And what else? Is there anything here? Unlock is not allowed. So again, so I'll simply disable this for my play state also, right? And yeah, so here you go. Now if you see here, there is no compiler warning or any error because we are still satisfying the interface, right? The state func interface is still being implemented by this default state. And once you embed one structure into another structure, right, what happens is the wrapping structure basically implements the functionality. So once we embed this default state structure into the play state, basically the play state now implements all these functionalities, right? And the one which we give explicitly is the one which takes the preference or basically which overrides the default implementation. So again, if I run the same set of commands, I should get the same output. Okay, so now since I have more than one file, I have to run the approach to